Okay, today we're picking up where we left off with yesterday's video. So we're on the bottom of page 2 of our Chapter 7 notes packet, working on the multiplication problems here. We have 4 multiplication problems at the bottom of page 2. All right, so we have some multiplication problems. Now, just as when we were multiplying like rational expressions, we would divide out common factors. Divide out common factors to numerators and denominators first. So divide out common factors to numerators and denominators. All right, so instead of starting to actually multiply the numerators, multiply the denominators, all right, let's divide things out that are common. For example, the 4 and the 12, right, that will reduce, dividing each by 4. This y in the numerator divides out with this y in the denominator. The x divides out with the x. And that looks to be it. So it seems like we have x to the third for a numerator and 3y squared for a denominator. So this is our result. Number 2. The 3 and the 6 reduce. The 2 and the 8 reduce. The 4 and the 12 reduce. Now, I have this y to the negative 3 and the y to the negative 4. You can think of this, well, in different ways. But if I do this, I have a y to the positive 3 in the numerator, a 3 in the denominator, a y, and the y to negative 4 is coming down into the denominator, y to the positive 4. And this y to the third divides out with 3 of these y to the fourth, leaving us with y. So our answer is 1 over 3 y times y is y squared. So 1 over 3y squared. Number 3. Well, let's take a look at the coefficients. The 2 and the 20 reduce, 1 and 10. This x to the third times x to the first is x to the fourth. So this is an x to the fourth that will divide into x to the 14th, leaving you with x to the 10th. If I bring the y to the negative 6 down into the denominator, I have 10 y to the 10th, x to the 10th, over y to the 6th. And the y to the 6th and the y to the 10th reduce, leaving us with y to the 4th. So our answer is 10. I'm just going to write it alphabetically. It's standard to write the x before the y. X to the 10th, y to the 4th. All right, for number 4, well, we have this 3x to the negative 3 raised to the second, so we have a product raised to a power, so let's distribute that. So that would be 7 to the second, which is 49. X to the negative 3 raised to the second. Remember, you multiply those exponents. That would be x to the negative 6 times, well, x to the 5th times x to the 1st is x to the 6th. So this leaves us with 49. X to the negative 6 times x to the 6. Remember, you're adding the exponents. That's going to be x to the 0. And x to the 0, remember, is 1. So this is simply equal to 49. Next, page 3. We want to write the expression without a denominator for the first two problems. So without a denominator. So that means we'll use our rules in that we have 4a squared b divided by a to the 4th. So this would equal 4. Now a squared divided by a to the 4th, since we don't want a denominator, we'll actually subtract the exponents, right? Subtract the exponents when dividing. So this would be a to the negative 2 and then b. Number 2. There's more than one approach, right? I can subtract the exponents. A squared divided by a to the negative 4. It's going to be 2 minus negative 4, which would be 2 plus 4, which is 6, right? Or I can bring this up with a positive exponent. So I'll have 4, a to the second, a to the 4th, b, which is equal to 4, a to the 6th, b. We'll still end up with the same result. Just more than one approach for many of these problems. For the next 4, we want to write the expression using only positive exponents. Only positive exponents, so that means whenever we have a negative exponent, we want to move it so that it is positive. So this x to the negative 3 in the numerator will go down into the denominator. So we'll have 3 over x to the 3rd, y to the 3rd. Number 4, I'll take anything that has negative exponents and move them so that their exponents are positive. So this will be 5x squared y. X to the negative 3 has come up to be x to the positive 3. And y, I wrote over that, not sure what that is. That's y to the 6. Sorry about that. And z to the negative 6 has come down to be in the denominator as z to the positive 6. Now reduce wherever possible. Just the y and y to the 6 will leave me with a y to the 5th in the denominator. And then multiplying x to the 2nd times x to the 3rd is x to the 5th. So 5x to the 5th, y to the 5th, z to the 6th. There we have the expression written with only positive exponents. Number 5. Let's move these around so that we have positive exponents. All right, but see here, please. C to the negative 7, c to the negative divided by c to the negative 7. They're just going to divide right out, right? Okay, so I have 5, and then b times b to the 3rd over, excuse me, I said 5, but this is 4. 2 a to the 3rd times the a squared. And now these can reduce. So I have 2b to the 4th over a to the 5th. Number 6. Well, right away, with those coefficients, I see that I can reduce them, but maybe I'll hold off. All right, so this is coming down, this is moving up. So we have 30. X to the second is now in the numerator, y to the fifth, over negative 15. X to the fifth is now in the denominator, y to the third. And now reduce negative 15 into 30, negative 2 times. X squared, x to the fifth, x to the third in the denominator, y to the fifth divided by y to the third, y squared in the numerator. So negative 2y squared over x to the third. Our next group of questions, we want to describe the mistake. In number 7, we have negative 2 squared times negative 2 to the third. Answer is 4 to the fifth. No, that's not correct. Should be same basis, negative 2, you copy that. And what do you do with the exponents? You add the exponents. 5. All right, so you remember, you keep the base. You don't do negative 2 times negative 2 and get 4. You copy that base. Number 8, x to the 8th divided by x squared is equal to x to the 4th. That's a mistake. Should be x to the 8 minus 2, which is x to the 6th. Right? You subtract the exponents. You don't divide the exponents. Number 9, x to the 4th times x to the 3rd. Keep the base. What do? You add the exponents. So it should be x to the 4 plus 3, which is x to the 7th. In the last 4 problems, we want to evaluate each function for the given value. We don't want to use a calculator here. Okay, so we have f of x equals x to the negative 3 times x to the negative 1. And we want to evaluate f of 2. So we simply replace our x's with values of 2. All right. Oops, this is supposed to be a negative 1, sorry. So 2 to the negative 3 times 2 to the negative 1 is 2 to the negative 4, and then 2 to the negative 4. Writing it with a positive exponent would be 1 over 2 to the positive 4, and 2 to the 4th is 16. So this would be equivalent to 1/16. Next, we want to evaluate f of 1. F of 1 equals 2 times 2/3 raised to the negative 1 plus 4 times 2/3 raised to the negative 1. Okay, so now just the 2/3 is raised to the negative 1, so take care of the negative, invert the fraction. So we'll have 2 times 3/2. And the same with our other exponent of negative 1. This will be 4 times 3/2. 2 times 3/2, 2's divide out, this is 3, plus 4 times 3/2, 2 goes into 4 twice, 2 times 3 is 6. So 3 plus 6 is 9. Number 3, we're evaluating f of negative 3. All right, so we're replacing our x's with negative 3. So we want 3 times negative 3 raised to the negative 2 plus 6 times negative 3 raised to the negative 2, and the whole thing raised to the 3rd power. Oh, well, let's work inside parentheses here. Taking care of the negative exponent, we would write this as 1 over negative 3 to the positive 2. Same thing here. This would be 1 over negative 3 to the positive 2. Negative 3 squared is 9, so I want 3 times. So I end up with 3 times 1/9 plus 6 times 1/9. All right, 3 times 1/9 is 1/3. And 6 times 1/9, 6/9 is equivalent to 2/3. And what's 1/3 plus 2/3? 3/3, which is equivalent to 1. And then 1 raised to the 3rd power is 1. And our last one. We want to evaluate f of 2. Replacing our x's with 2. So we have 2 times 2 to the 0 power plus 2 raised to the negative 2 over 2 raised to the negative 1. Okay, well 2 to 0 is 1, so that's simply 2 times 1, which is 2. Plus, to take care of the negative, I would write this as 1 over 2 squared. And again, to take care of the negative 1, we would write this as 1 over 2 to the positive 1. So we have 2 plus 1/4 divided by 1/2. Looks like a complex fraction to me, so let's multiply by the least common denominator of all the denominators. Right? The least common denominator of all the denominators of 1, 4, and 2 is 4. Right? So go through and multiply every term by 4. Okay, and here we have 4 times 2 is 8 plus 1/4 times 4, the 4's divide out, that's just 1. And 1/2 times 4, 2 goes into 4 twice. 2 times 1 is 2. 8 plus 1 is 9. So our answer is 9/2. And this concludes tonight's video.